Thin layer chromatography or TLC is a chromatography technique used to separate non-volatile mixtures. Like other techniques, it also depends on the separation principle selective adsorption. As the name, it is done by thin, uniform layer of adsorbent material such as alumina or silica gel or cellulose. The most commonly used stationary phases are adsorbent. Example fine powders of silica gel, alumina, and cellulose. They are specially prepared for TLC. Many of these are available with a fluorescent compound, example zinc sulfide, incorporated in order to facilitate the detection of the resolved components of the mixtures when viewed under UV light. Silica gel is slightly acidic, whereas alumina is slightly basic, but neutral alumina is also available. Silica gel and alumina particles contain hydroxyl groups on their surface which will form hydrogen bond with polar molecules. Alumina is preferred for the separation of weakly polar compounds, but silica gel is preferred for polar compounds such as amino acid and sugars. Support used for the stationary phase in TLC is a glass plate, aluminium metal plate, or plastic strip. The mobile phase is a suitable liquid solvent or mixture of solvents. Water is not usually used because it doesn't mix up that much with organic compounds. Movement of the solute increases with increasing solvent polarity. The solvent is employed in the form of a pool at the bottom of the developing chamber. Usually, the solvent or element is made to ascend on the plate, hence the name ascending TLC. The solvent travels through the system by capillary action. The solvent velocity is determined by the nature and packing structure of the adsorbent.
Of thin layer chromatography is similar to paper chromatography except that a thin layer of some inert material such as Al2O3, MgO, SiO2 is used as a substrate instead of the paper. A layer of one of these oxides is made from slurry of powder in a suitable inert solvent. The slurry is spread evenly over a flat surface and dried. It may be spread manually or mechanically. The advantages of using inert substances instead of paper is that more reactive developing reagents such as strong acids can be used to detect the compounds without destroying the substrate. It is especially useful for the separation and analysis of high molecular weight biochemical compounds. A wide variety of mixtures such as amino acids, dyes, food colorants, drugs, sugars, natural products, and insecticides may be separated and identified.
Working of thin layer chromatography. The stationary phase that is applied to the plate is made to dry and stabilize. To apply sample spots, thin marks are made out at the bottom of the plate with the help of a pencil. Apply sample solutions to the marked spots, pour the mobile phase into the TLC chamber, and to maintain equal humidity, place a moistened filter paper in the mobile phase. Place the plate in the TLC chamber and close it with a lid. It is kept in such a way that the sample faces the mobile phase. Immerse the plate for development. Remember to keep the sample spots well above the level of the mobile phase. Do not immerse it in the solvent. Wait till the development of spots. Once the spots are developed, take out the plates and dry them. Sample spots can be observed under a UV light chamber.
Measuring RF values. RF stands for retention factor. RF value is the ratio of distance traveled by the component to the distance traveled by the solvent friend. RF is equal to distance traveled by the component divided by distance traveled by the solvent friend. Applications of TLC. TLC is widely used by many industries and research fields, including pharmaceuticals, clinical testing, environmental toxicology, food, water, and pesticide analysis, cosmetics, etc. Typical applications of TLC include analysis of drug residues and antibiotics in food and environmental samples, identification and quantification of colors, ingredients, preservatives, and sweetening agents in food and cosmetic products, quality control and purity testing of pharmaceutical formulations, rapid, high throughput screening prior to HPLC, examination of chemical reactions for completion.